Worldwide, the building sector accounts for about 40% of energy and process-related CO2 emissions, contributing significantly to global warming. As a result, producing and using eco-friendly building materials has become crucial in addressing the whole-life carbon emissions of both existing and new buildings. Today, biomasses like wood, bamboo, hemp, miscanthus, straw, and cocoa shells are gaining popularity and are widely used in various building applications. I will now focus on two leading bio-based materials, cross-laminated timber and hempcrete, that have been commercially introduced. CLT is a prime example of how timber has been revolutionized for structural applications. Made from timber laminations glued together, CLT is used in walls, floors, and other load-bearing structures. With its low carbon footprint, high strength-to-weight ratio, and ease of installation, CLT offers a high-value alternative to mineral-based construction materials. CLT can theoretically be made from any type of wood. In 2023, the global CLT market was valued at $1.02 billion and is projected to grow at a compound annual growth rate of 14.4% from 2024 to 2032. Europe leads the market with a value of $590.5 million, accounting for 57.64% of the global share, driven by key players such as Austria and Germany. CLT production has already been standardized, with design guidelines developed to monitor CLT construction. What are the benefits of CLT to the environment? Using CLT instead of conventional concrete for multi-story buildings can lead to significant GHG emission savings, around 40% on average. CLT stores carbon during its service life, turning buildings into potential carbon sinks. In production phase, timber structures reduce the global warming potential impact by 30%. In use phase, CLT buildings are less energy intensive to operate and emit less than half the embodied CO2 of conventional buildings. No assumptions are made about decommissioning or the post-recycling phase because the current generation of CLT buildings has not yet reached the end of its service life. There are plenty of companies producing CLT, and the technology is pretty mature, with each holding a decent share of the market. KLH Massive Holts. GmbH is known for producing high-quality CLT panels made from spruce and bonded with formaldehyde-free adhesives. The company prioritizes sustainability by sourcing timber from certified sustainable forests and ensuring all products carry CE certification. KLH offers customized CLT panels with various surface treatments to meet diverse application needs. Their panels are used in residential, public, industrial buildings, and even bridge construction. Mike & Lamwood was one of the first companies in Japan to work with CLT. They use locally sourced timber to make products certified for 2-hour fire resistance. With earthquakes being so common in Japan, their CLT is built to handle earthquakes and has proven its strength in intense seismic tests. And the flexibility and easy replacement of wooden structures makes CLT a popular choice over concrete, perfectly suited for the country's needs. Another promising bio-based material is hempcrete that is made from a mix of hemp shivs and mineral cementitious materials like lime and Portland cement. It can be produced in various compositions and methods for walls, floors, and roofs. For walls, hempcrete is used in non-load-bearing applications because it lacks sufficient compressive strength, unlike CLT. In 2017, Asia produced 52.4% of the world's hemp, led by China. Europe accounted for 40.6%, with France as the largest producer, over 60%, followed by Germany and the Netherlands. The global hempcrete market exceeded $26.8 billion in 2023 and is projected to grow at a compound annual growth rate of over 5% from 2024 to 2032. Asia Pacific, the leading region, accounted for approximately 32% of the market share, with the global market segmented into North America, Europe, Asia Pacific, Latin America, and the Middle East and Africa. What are the benefits of hempcrete to the environment? The life cycle assessment shows the impact on global warming potential, improving as the proportion of hemp increases. Carbon negativity is achieved when hemp makes up at least 20% of the mix by weight. Despite variations in GWP depending on the mix design and local conditions, hempcrete consistently demonstrates net negative carbon potential. In production phase, hemp absorbs CO2 during growth, acting as an effective carbon sink. However, transport is the most energy-intensive step, contributing 50.3% of hemp's total embodied energy, followed by industrial and agricultural processing. In construction phase, while hempcrete production emits CO2, lime recarbonation sequesters 18 kilograms of CO2 per cubic meter. This carbonation process helps offset emissions during production and construction. In use phase, hempcrete's hygrothermal properties, moisture buffering, and thermal inertia improve energy efficiency, reducing heating and cooling needs by 10 to 17%. CO2 is further absorbed through the carbonation of calcium hydroxide, though complete carbonation throughout the building's lifespan is unlikely. The end-of-life phase is excluded since no hempcrete structure has yet been dismantled. Denagro Hemp Group is a leader in hemp construction, cultivating over 1,300 hectares of hemp annually, backed by 25 years of expertise in hemp processing. They produce prefabricated hemp lime panels for facades, roofs, and floors with sizes up to 6 by 3 meters. These panels enable homes to be built windproof and watertight in just 1 week. Homeland Hempcrete, which entered the market when industrial hemp production was legalized in the U.S., initially used traditional cast-in-place methods. They now offer pre-made, pre-cured hemp wall panels, ensuring consistent quality and quick installation, significantly reducing build time and allowing finishes to be applied immediately after installation. Equilibrium specializes in natural construction and insulation systems, using hemp and lime-based compounds. These eco-friendly materials are recyclable, biodegradable, and promote healthier living environments by regulating internal temperature and humidity. They help buildings achieve high energy efficiency standards, such as Passive House or Zero Energy certifications. Hempblock Canada specializes in Canada's only load-bearing hempcrete block system, designed with interlocking blocks that eliminate the need for mortar. This innovation enhances structural strength while simplifying construction. Its load-bearing capability makes it stand out in the hempcrete market, enabling efficient and durable building solutions. Barriers to wider hempcrete adoption include legal and market challenges due to hemp's association with marijuana, requiring ongoing advocacy to shift perceptions. Additionally, hempcrete's higher initial cost, such as 64% more than traditional materials in the UK, necessitates consideration of long-term energy savings and environmental benefits to justify the investment. Therefore, CLT and hempcrete are both sustainable materials with distinct applications. CLT is ideal for structural elements like walls and floors, especially in taller buildings, while hempcrete is mainly used for insulation and energy efficiency in low-rise homes. CLT is more commercially established, whereas hempcrete is still gaining popularity, particularly in eco-friendly projects.